Hi aspirants, this is our part 1, the series that we have promised that we will continue like to upload of about all the subjects. You can go and check our YouTube channel. You will find it for free. These series are mainly for the benefit of our remote areas, people, students and aspirants who are trying to prepare for NPSC and NSSB. Hopefully these series will help them a lot. You can guys complete your syllabus only through the MCQ series. Now, this part 1 video is for geography. Welcome all of you in learning geography through MCQ series. Without any delay, let's start our geography or geomorphology part. Continental drift theory was proposed by, remember friends, in when we start geography for any civil service of state or NPSC, right, we need to learn the geography from the scratch. Now when we talk about scratch, there is first one part of geography comes, that is called geomorphology. Geomorphology gives us a holistic and wider idea about the physical status of our planet. Now, this planet, how it formed, how many people have contributed their life, their theories, their experiments to understand this, all those basics sometimes we got to learn. Now, the geomorphology part, we generally start from the geological time scale, but the theory which we start initially is continental drift theory. This theory tells us about the continents moving from one place to another. All right, it was first discovered by the Alfred Wegener around 1912. Jiske we understood that our planet is not constant, the continents are not constant, they keep on moving from one place to another. Even that makes us understand that the continents who are available in this planet were not as it looks today. So, continental drift theory is one kind of theory which explains us about the continents movement. Now, as I give you the answer, Arthur Holmes, Alfred Wagner, Harry Hess, Wine, and Matthews. So the clear and cut answer is Alfred Wegener. He also known as the father of continental drift. Okay, he was the first man who told us about the movement of continents, and therefore he got this title. Alfred Wegener was the first, or let's say one of the very pronounced geomorphologist, geophysicist, and geometeorologist. Okay. Now, next question. According to Wegener, Pangea broke into. Remember when Alfred Wegener gave his theory of continental drift, he also explained certain things. That in first time he said that initially around 300 million years ago, the earth was only having one continent, was that known as Pangea. This Pangea supercontinent gradually broke into two different gigantic continents named as Gondwana and Laurasia. Gondwana remained in southern part of the earth and Laurasia moved towards the northern part of the earth. That means crossed equator, the center of equator. And when it entered in upper part, there were two gigantic continents available after Pangea. So the question is, according to Wagner, Pangea broke into Laurasia and Gondwana land, Eurasia and Africa, Pacifica, and Angara land, Eurasia and Atlantis. So the right answer to our question is Laurasia and Gondwana land. These were the two lands who formed after breakdown of Pangea. Next, which evidence did not support continental drift? Fit of coastlines, fossil similarities, paleoclimatic evidence, distribution of ocean trenches. Actually, when we talk about continental drift theory, to prove his Alfred Wegener to prove his theory of continental movement, he provided some evidences which included jigsaw fit of the continents, means the whole continents in our world are like a zigzag plus puzzle who can fit with each other's coastal areas. So this was jigsaw fit. Second was the evidences of fossil, that same type of fossil is found in different continents who are not sharing same type of climate anymore. That means those fossils belong to when these lands were together and they were sharing same type of climate. So fossils were also correct. Paleomagnetic or paleoclimatic evidence. Paleoclimatic evidences are generally not done. They are generally paleomagnetic or distribution of oceanic trenches. So A and B is correct. The option is C and D. So you can go for D. Sorry. All right. D, paleoclimatic is also one kind of evidence which actually provides the fossil similarities, and distribution of the ocean trenches doesn't have link with the evidences connected to the continental drift. Okay. Next, remember this topic is important from the point of view of mains. Mains already, like a few years back, NPSC have asked this: what is continental drift theory? Okay, in the mains. So remember that. Mains reason Wegener's theory was rejected initially: lack of fossil evidence, lack of geological evidence, no mechanism of for movement, no climatic evidence. Remember, we were having some evidences who were able to prove that continent is moving because of because of fossils, because of your breakdown. So we were having fossil evidence, we were having geological evidence, but yes, no mechanism of movement. For movement हम लोग को mechanism नहीं पता था. C was the correct answer. Alfred Wegener, in his entire theory, he said that initially Pangaea was available. Pangaea broken down into two different lands: Gondwana land in south, Laurasia in north. Gondwana later on divided into many multiple lands, that is modern day Africa, India, South America, Australia, Madagascar, and Antarctica. And Laurasia developed into several other different lands: North America, Europe, Asia. All right, these kind of lands were the part of Laurasia. So there was no evidence to define why these continents were moving. Okay, there was no reason defined by the Alfred Wegener. That was the only drawback of this theory, and people actually criticized this theory on that regard. But the continents are moving, that is perfectly correct. They were moving. All right, we still have the evidence of continents moving, that we all know that Greenland always move 1.3, 1.2, 1.5 centimeter every year from its place. So continental drift theory is correct. But see, why? See, because there is no mechanism known by this theory that why these continents are breaking and moving. All right, so C is the right answer. Next question. Seafloor spreading was proposed by Alfred Wegener, Harry Has, Tuzo Wilson, and Wayne Matthews. Seafloor spreading is technically another next level condition or understanding about our continents, that continents move from each other, away from each other. So if there is a ocean, they also get spreaded. All right, so that is called seafloor spreading. This was given by Harry Has. All right, Alfred Wegener gave continental drift theory, but Harry Has gave the seafloor spreading theory. So the right answer is B, Harry Has. The strongest evidence for seafloor spreading is marine fossils, heat flow, magnetic anomalies on ocean floor, ocean salinity variation. Remember, the strongest evidence for seafloor spreading is magnetic anomalies on oceanic floor. All right, they actually have made the magnetic anomalies. Also, more another close related answer is heat flow, but since the center part where the land is moving away from each other, the lava is exposed. We generally call it ridges, oceanic ridges in the middle of ocean, which causes spread of ocean. All right, so the right answer can be C, magnetic anomalies. The age of oceanic crust is uniform, oldest at mid-ocean ridge, youngest at mid-ocean ridge, same as continental crust. So, the age of oceanic crust is always C, youngest at mid-oceanic ridge, because from here new lands comes from bottom lava gets solidified, comes out, and seafloor spreads. All right, so right answer is C. Next, plate boundaries with constructive forces are transform boundaries, convergent boundaries, divergent boundaries, passive margins. Remember, after seafloor spreading, we came to know that because of internal magma of Earth that is coming from mantle is the reason who is causing continental movement. Now, because of these continents, why these continents are moving? Because it is because mainly the magma which is coming and striking the crust from its beneath. Now, when these continents crust, they break down the plates, they convert into small, small pieces. That means our crust is broken into several pieces in this planet. And at floating over asthenospheric layer, we will be discussing the different layers of the internal earth that we will make a separate video. Upcoming videos part 2 part 3 mein aayega, but we will understand that upper part of the earth is crust, which is divided into lithosphere, asthenosphere. Lithosphere is hard, asthenosphere is semi molten. So lithosphere is the one who been cracked by the magmatic thrust and divided into several pieces. And lithosphere, above lithosphere, continents and oceans are stay. All right. Now, if lithosphere is broken, that is called plates. Now, broken pieces of lithosphere over the crust is known as plates. These plates are called moving from one place to another. So, continents also move from one place to another. We call it plate tectonics. Okay. After seafloor spreading theory, we came to know that plate tectonics works. Now, plate tectonics has three different movements: transform, convergent, divergent. Transform is two plates crossing each other's path, not colliding, not going away from each other. Convergent, two plates are going to collide because they are in the same path. And divergent, they are moving away from each other, they are not colliding each other. Now, divergent causes new land formations because they construct ridges from the beneath of ocean, and when this lava comes out, it gets solidified. Eventually, if it comes from above the surface of water, it will take the shape of island and big islands. They can even convert them into continents. So technically, plate boundaries with constructive means manufacturing more lands. Okay, so it is a constructive who can divergent boundaries. Divergent boundaries makes new landforms in the world. So we call divergent boundary as a constructive boundary. So this C is the right answer. Next, deep ocean trenches are associated with divergent boundaries, transform boundaries, convergent boundaries, hotspots. Remember, deep ocean trenches are formed usually when two plates gets closer and collides. When these two plates collides, that they create the collision impact so deep that the deep trenches forms at that collision spot. That is called as the convergent boundary. So technically, trenches are formed generally in convergent boundaries. So convergent boundary is the right answer. Next question. Okay, let's see 10th number. Himalayan mountains were formed due to ocean continent convergence, continent convergence, divergence, transform motion. So we all know that Himalayan mountains were born 65 million years back in this era called Cenozoic era, Tertiary period, Eocene epoch. But the continents who got collided was Indian subcontinent and Eurasian continent. But these two subcontinents and continents are the part of continental plate. So technically two continental plate collided and formed the Himalayas. That means B is the right answer. Okay, next question. The Andes Mountains formed due to ocean convergence, ocean continent convergence, and divergence. Andes Mountain is technically found in western parts of South America, which includes Bolivia, Colombia, including Peru and Chile kind of countries. The mountain of South America, that is Andes, in fact it is the longest mountain in the world. All right, it was formed due to Pacific plate, which is oceanic plate, collision with South American plate collision. South American plate is purely continental plate and Pacific plate is purely oceanic plate. So B is the right answer, in which oceanic and continental plate convergence happened. Now, which plate boundary experienced high volcanic activity but shallow earthquake? Now, divergent transform continental collision, passive margins. Now, we have three major plate tectonic boundaries: divergent, transform, and convergence. So, technically, A, B, C are representing that, and D is passive margins, different margins of different plates. So, technically, the boundaries where high volcanic activities are found are generally continental collisions होते हैं, plus the upper part, that is transform collisions and divergent collisions. So we can say divergence because in this case, will the very less earthquake conditions, magma comes out and forms ridges. So A should be the right answer. Okay. Next, what separates the crust from the mantle? Lehmann discontinuity, Gutenberg discontinuity, Mohorovic discontinuity, and Conrad discontinuity. So everybody knows about it. This is most common part of interior of Earth. Everyone knows, that is Mohorovic discontinuity, that is C. Next question. The outer core of the Earth is solid, liquid, plastic, or semi-solid. So we all know it's semi-solid condition, which is also we consider also liquid core bhi kehte hain, we also call it liquid core. B goes to the more towards the question's answer apart from D. So B is the right answer. Next, which layer is responsible for Earth's magnetic field? Inner core, mantle, liquid outer core, crust. So technically, outer core of Earth is responsible for geomagnetic conditions. We also call it Earth magnetic field, or you can also call it geomagnetic field. All right. So liquid out core is the answer. Next question. The asthenosphere is rigid and brittle, partially molten and ductile, outer part of the core, and solid part crust. Alright, A cannot be possible. Asthenosphere is just found below than lithosphere. It is semi-molten region. Partially molten and ductile, we can consider that. Outer part of the core, no, we cannot consider that. Solid upper core, that is also wrong. So B is the right answer. Next, ring of fire is associated with divergent boundaries, mid-ocean ridges, subduction zone, or transform boundaries. Ring of fire is actually found in subduction zones where Pacific plate is going below than the Eurasian plate and other side both American plates. So subduction zone is the right answer, C. Okay. Next, what is subduction zone? From where the one plate goes after collision goes down towards the inner part of the earth. Transform boundaries are characterized by high volcanism, crust formation, crust destruction, littoral slip, and earthquakes. The transform boundaries are generally they slip and causes earthquake. All right. So D is the right answer. Hotspot volcanism occurs due to convergent boundaries, mantle plumes, ocean currents, continental drift. Hotspot volcanism, generally volcanism is a condition of which from cracks the mantle plumes comes out. All right. So mantle plumes generally is the right answer. Mantle plumes means the magma which comes up through the convectional current and release it from the mountains. Which statement is correct about continental and oceanic crust? Oceanic crust is thicker than continental crust. No, that's incorrect. Continental crust is thicker than oceanic crust. Okay. Continental crust is denser than oceanic crust. That's correct. Sorry, no, it's not correct. Oceanic crust is more denser than continental crust. Oceanic crust is mainly basaltic. This option is correct. Continental crust is mainly basaltic. No, D is not correct, B is not correct, and A is not correct. Oceanic bottom is generally formed by the solidification of magma which comes out from mantle. All right, and they immediately convert into solid without mixing up with silica. So mostly the continental bottoms are basaltic by nature because of less addition or negligible addition of silica, you can consider. All right, so this is it with our first part of our Learn Geography through MCQ series. I hope you guys will have benefit of these questions. You can revise it. Any question you will have, please comment on the comment section. And tomorrow we will come up with the part 2 of this session. Thank you.